So for your warm-up today, started off with some rats. What we're looking at for this one is we're kind of doing a review of normal curve here, of our standard deviation and expected value, what happens when we do manipulations with that, and then even back to some basic probability, because all of this stuff builds up together. So let's take a look at the answers for this. I would unfreeze. Unfreeze! Here we go. I also want to kind of make sure that we're focusing on what kind of stuff you need to write. What needs to be shown? Answer to that, everything. So, for number one, you want to make sure that you define your variable. Talking about the weight of them, they're rats. Are rats. And it said it followed a normal model, because now we're going to talk about the thing, describe the thing, shape, center, spread. Anytime I'm asking you to find probability, you need to find z-score. And I get it. Right now, it doesn't make sense. It's like, why? Well, the answer is going to come in the next couple units. Over the next couple of units. Not in the next, but you know. Okay? So the probability should have been 0.1357. Questions? No? Swiggity? When we draw, label, and shade a normal model, a label is usually important, especially since it says a label. So is drawing and shading, because you know it did say that as well. It said find the probability that were between 700 and 900. I just did my z-scores over here. So my z-scores were negative 1.6 and positive 0.83. And I just got 0.489. Hopefully those are okay. We remember our normal CDF, how to do that. Calc speak, not appropriate. All right. Okay, then the fun stuff. You guys have not been a very big fan of this, but that's okay. You just gotta get used to those formulas. A is talking only about the bedroom, so I don't care if you used X or Y or B and K, whatever. I said X was the area of my bedroom. Those were the numbers I was dealing with. Yes, sir. I did. I see that now. So that should have been 200 here, which would have made that 600. Thank you for paying attention to that, because apparently I don't. I used the correct standard deviation. And this is where I've seen people have the most issues, is with the standard deviation. As I would expect, expected values work out nicely. But no, sad. Okay. Standard deviation, however, what you need to remember is, when do I just deal with 3 times? When is it 3 squared? Since this is just 3 separate things, it's 3 times 65 squared, and then I take the square root of that whole thing. If I was saying I was going to triple the area of a bedroom, that would be different. Okay. Again, I'm kind of hoping that the expected value for B is what you would expect. And the expected value for all of that extra stuff in that house would be 1,100 square feet. Or feet squared, depending upon how you want to say it. Are y'all good with that? Something that I'm not going to give you a problem like this on a test or quiz, so I want to work it out for you, is the standard deviation. Again, we're talking about for B that the whole, what is the average and standard deviation of the area for living after the bedrooms and kitchen are excluded. So we know that the living is made up of 3 bedrooms, a kitchen, and some other stuff. Okay? So what I'm trying to do is I'm trying to figure out what that stuff is going to be for the standard deviation. That means what I'm looking at here is that the standard deviation of the living room, I have to somehow write that in terms of the standard deviation of all this other junk. The living room had a standard deviation of 25 feet squared. We don't do math with standard deviation. What do we do math with? Variance. So that means I'm going to do my variance here instead, using my variance rules. I will say 225 squared. Variances here will square. Variance of one, variance of another. Variance of the third. Variance of the y. And the variance of my other stuff. This isn't like algebra where I could just initially solve for my stuff and then calculate the variance on everything else. It gets really confusing if you try to do that because of the Pythagorean theorem. So that means I have 225 squared is 3 times the bedroom was 65 squared plus the kitchen, who was 45. Thank you. Squared plus the variance of my other stuff squared. So I have to go through and I have to solve that. And again, using the Pythagorean theorem to solve that doesn't work out quite too nice. But you get that the standard deviation of that stuff is going to be equal to 200.81 cubic feet. Square feet. Why did I all of a sudden? You don't talk about it. Yes? Augsburger! Frickin' A. Come on, woman. Okay, so let's actually do this math. So I would do 225 squared minus 3 times 65 squared minus 45 squared. Take the square root of that sucker. Squared. Here we go. You know, it really helps if I can keep those things straight. Yes, sir. Repeat that for me, please. Yeah, and the definition of multiplication, if I've got this plus this plus this and they're all the same. Oh, I didn't do any, my equation is just addition. But what I'm doing here is now I'm solving the equation when I've got everything down to its bits and pieces. Yes. Yes, but not until you are in your variance form. Because the variance level is the level that we are able to do the math on. Okay? And again, I'm not going to give you something like that on a test or quiz. It's just a nice thing to kind of talk about. Okay, so, yes, ma'am. Because it said that we were talking here about the total area of the house has an expected value and a standard deviation. The 225 was the total house standard deviation. So what I did is I put it into an equation. I said the total house standard deviation squared is each room and anything else added up. Okay? All right, so let's just finish this sucker off with the last problem. Number 3, the probability was 0.4615. My pen started dying here. For B, probability that it's digital. If they listen to music on a CD, that means we already have CD. What's the probability that they listen to digital music? That's the probability of D, digital given CD. So the AND goes on top. The total CD goes on bottom. And then for part C, probability of D, I can compare it to anything else as long as the D is in the first place. So I compared it to D given CD, which is what I already had. Those two are not the same, therefore it is not independent. Okay? Didn't know if that was a lean back for hand raise or not. Okay. All right. Beep, 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 beep. We did that. Oh, I didn't even think about this one. I didn't realize there was a number 4. Did y'all do number 4? No? Why don't you do number 4? Come on, Augsburger. That was sad. Let's do number 4. Y'all. Okay, let's take a look at these answers. I can figure out where it is. There it is. Okay. So the probability you win $20 3 times in a row is 0.002. For part B, this table here is for how many games? That's 1 game. But why didn't I do the expected value of x plus x plus x plus x 10 times? Because it's 0. If 1 game has an expected value of 0, how much should I expect to win from 100 games? 0. Okay. And C goes back to that question y'all love so much. You're due for a win. No. They should be independent. There is no law of averages. It's only in the extreme long run that you would expect things to average out. Okay? Because if you said no, I would move on anyway. All right. We're still talking about probability models today. The nice thing about the probability unit, like you saw with this form up here, is even though, yes, I'm technically moving on, these old rules are not going anywhere. They're very, very important. What did we talk about last class? Which probability model? We talked about one very in particular. We said Bernoulli led to geometric. Geometric, I use the geometric model when I'm trying to find the probability that I keep going until I have a win, right? And for that, I needed bits, where B stood for binary, so it had to be success or failure, whatever you wanted to define that as. I was independent. Independent meant one did not affect the other, or if we were taking a sample, we had to make sure that that sample was less than 10% of the whole size. T stood for trials, because we're counting the trials until I get a success. And S was probability of success stayed the same. Good, very nice. Today we're moving to the binomial model. Okay? Don't freak out. It is one, well, actually, sometimes this does make you freak out. There's one tiny difference between geometric and binomial. For a binomial model, no matter what, we have a fixed number of trials. So no matter what, you're going, instead of keep shooting until you get that free throw in, I'm giving you 10 shots. That's it. I want to know the probability that out of those 10 shots, you make 3 of them. No matter what, you have a multiple choice test and you're randomly guessing on every one of them. I want to know on a 5-question test, what's the probability that you get them all right? Fixed number of questions. Everybody's doing the same thing. We want to know the probabilities for each separate outcome. When we're talking about binomial, like geometric, I asked you when we're describing a geometric model, we put GEOM, and then in parentheses, just the probability. For binomial, it's binom, and then it's n equals, so what are your fixed number of trials? And what's the probability of success on any one of those trials? So for binomial distribution, it's very similar to geometric distribution. You got to have Bernoulli. What did Bernoulli say we needed to have? 2 outcomes, success or failure. We needed independence, couldn't affect each other or less than 10%. We needed same probability of success. Well, binomial, rather than dealing with bits, we got bins. Hey, Guess what? This is bis whether it's with bins or bits. That was really weird. I just came up with that. I probably should just leave that and never touch it again. Okay. So what? Yeah, it's on recording. Woohoo! So what do you think B stands for? Oh my gosh, you're all psychic. Lisa didn't say psychotic, which is where I was going with that. I is independent, imaginary, okay. Now T stood for trials because we're going to keep trying until we got it right. Number of trials here is set. And I'm telling you it before we even get started. Now this one's got to be different though, right? What does S stand for? Statistics. Sugar. Spaghetti. Can't be spaghetti. I'm trying. I fail, but I try. Successes. So what you need to keep track. You know what? I'm very confident in your guys' ability to identify whether something is Bernoulli or not. Woohoo! Binary. Woo! Independent. Woo! Probability of success stays the same. Woo! 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 But you've got to keep straight, and I want you to think about the way that I'm saying this. Geometric. Geo, go until. You hear what I'm saying? Geometric, go until. Binomial, number of trials is set. Geometric, go until. Binomial, number is set. Okay? Geometric ain't got no ends in it. No, it doesn't. There you go. I just checked. Okay. Binomial has no G's in it, so you do not go until. Try to think of that as your rule. So for the binomial model, remember how I gave you some yellow stuff for the geometric? You getting some yellow stuff for the binomial. Here is some things that you don't need to know. That's exactly what I said, that you don't need to know. Do you guys ever remember seeing this notation? Ooh, yes. If you had, sometimes they would do, I feel like a ballerina. They'd do the parentheses, and then on top they'd have a number, and on bottom they'd have a number, but there's no line in between. That is from combinatorics. That's how many combinations are possible when order is not important. It's like when we're talking about I'm going to have 3 kids, and I'm going to go until I have a boy. How many boys are possible? Well, depending on where that fell out, different things occur. So this is read as out of n, choose k. Don't worry, I'm not going to ask you problems that require that formula. And if they give you problems with that formula in, like they have done in previous AP exams, for crying out loud, tuck it into your calculator, see which one gives you the answer you wanted. Okay, so I'm not worried about that. I do want to make sure that you guys understand that n factorial is not n. We're in math, that's not an exclamation point, that's a factorial. It's not an excited n. It's n factorial, which means start multiplying all the way down until you get to 1. And again, because when we're talking about binomial, I don't care when I got those shots. I don't know when I'm making 10 free throws. I don't care when the 3 successes occurred. I just want to know what's the probability of getting 3. So, really, what do you need to know? You need to make sure that when you're talking about the binomial model, n is your fixed number of trials. It's set before you get going. Gee, want to take a guess what P is? Probability of success. And because I'd rather use a shorter thing than 1 minus P, I talk about Q. If P is success, Q is a failure. To me, it's just easier to write and talk about. And so when we define our random variable, we say X, in this case, is the number of successes in a set number of trials. When we were talking geometric, we said X was the number of trials until your first success. Go until. So this is how we differentiate between them. And if we have this, a set number of trials, the probability of success stays the same, and it's just a yes or no question, and we can define it as number of successes within n trials, we can use these formulas. Just write it down. I will make your life easier. Do not worry. And how I have written here NCX, out of n, choose x objects where order is not important. You will usually see that written for this class in this way, the parenthesis with an n on top, x on bottom. You just couldn't get it to type. I figured it out since then, but this is also what you will see in your calculator. So I'll give you a second to write that down, and then I will show you where to herk it is in your calculator. Where to herk. Okay, you guys get that written down? Let's grab them dark calculators. Boom, shakalaka. Anybody want to try to guesstimate where I might go? Oh my gosh, I hit the math button. Oh, you've seen this before. Probability, and then there's your NCR. The thing is, depending upon what version of a calculator you'll have, sometimes you need to push that button first, sometimes you put the number in first. So let's say I was talking about out of 10 free throws, how many different ways are there to get exactly 3 of them? 120. You can also do 10 and then NCR and then 3. It just depends upon your calculator. If you have a calculator with a pretty type, you can do it that way. Does that one not have pretty type? Woo, no. Okay, so you have to put the number in first for yours. So that's 10, and then math, NCR, 3. Okay. If you are not prompted with the little boxes on either side, type the 10 in first before you hit the NCR button. So it depends upon if you have a fat calculator versus a skinny calculator. In this case, fat is PHAT, pretty hot and tempting. Pretty hot and TI. Boom, fatty. Okay. I did just say that. Moving on. Read through this problem. You are going to get sick and tired of arrows today. You know, kind of like you're sick and tired of me every day. True dat. There you go. Every other day. The days you don't have me, I'm not quite so irritating. So, when we have these problems, and of course I did not include this in my notes to even write down, we need to start by writing down what's important. So if we're looking at A, we have her first bullseye comes on the third arrow. B, she misses the bullseye at least once. How do I need to do the work for this? The first thing that I need to do is I need to start talking about what my probabilities here are. P. What am I going to define P as? Probability of hitting the target. So that means because I can do probability, that hits my Bernoulli aspect. What else do I need? In order to do any of these, they're all Bernoulli. So I start with probability, binary. independence. So it said, assume that each shot is independent. Even if it said that in the paragraph, which it did, it said assume each shot is independent of the others. You must write that down. That is not optional. And then we define what that probability was. And if you didn't catch that before, the probability of hitting a target was 0.8. Now, A and B were asking two different questions. A was asking her first bullseye comes on the third arrow. What kind of distribution is that? Is that geometric or binomial? Geometric. Why is it geometric? Right. First bullseye comes on the third arrow, so that is geometric. Misses the bullseye at least once, that is binomial, because no matter what, we're talking about all 6 shots. So that means I really kind of have 2 different variables going here. I'm just going to identify them right from the get-go, so we only have to do it once. I'm going to say let X be the number of trials until a bullseye. That's not how you spell bullseye. Bulls does not have an E in it. And I'm going to let Y be the number of successes, or the number of, in this case, a success is a bullseye, in N shots. Do y'all understand what I'm talking about here? If I define it up first, it doesn't matter how many questions I deal with on this situation. I don't need to do that ever again, which is wonderful, which is why it's nice to do it up front. Now, A was asking for the probability that the bullseye or I should say the first bullseye, was on the third arrow. You don't need to write this part down. I'm just putting the question up here. Is this binomial or geometric? Geometric. So this is my geometric probability, where P was 0.8. So the probability that X occurred on the third arrow, how do I calculate that? Right. That means fail, or 0.2 squared, times 0.8. What you get? 0.032? Is that good? Okay. B was asking me a slightly different question. B was asking for the probability of getting, how many was that? Or missing at least once. Uh-oh. We have that phrase, at least. So when I'm going to be talking about at least, I'm going to do 1 minus the probability of no misses. So that's going to be 1 minus what? 0.2. And we were doing 6 shots. No misses. The hit is 0.8. So no misses is, a miss is 0.2. Oh, dear God. Hang on, sorry. Boop, boop, boop. So a probability of a miss is 0.2. We're talking about, here, this is why we write it out. Probability of hitting a target is 0.8. So this should be probability of no misses means probability of hitting all targets. Thank you. 0.8 to what? 6. Can anybody calculate that for me? .7379, was that what you said? Thank you. Oh dear God, that probability stuff is not going away! Even though we wish it would. All right. So we got those. Same sitch. I don't need to write it down again. Try C on your own. Okay? What'd you get? Start to the point. 0.0, 0. Take a guess. You're probably right if you've gotten that far right. Okay, no. I was hoping to be able to say yes. I was like really, really believing in it. So this says the probability to have a bullseye on the 4th or the 5th. Or means we add. So probability x is 4 plus the probability that x is 5. That's what I get her. Okay? Answer. The reason why I would not use the C thing is because saying that I would have as you have where I don't care where they occurred. This is specifically saying it occurs on either that 4th or that 5th. And not only that, but it's talking about the first success. Not just the 4th or the 5th has a success, but that one is the first one to be a success. Okay? The next one says the probability of getting exactly 4 bullseyes. What is that? That's going to be binomial. Everybody okay? So I'm talking here about the probability. That's supposed to be a D, not a P. The probability of 4 bullseyes. For this one, I'm using the idea that Y follows a binomial, and I don't actually need to write the whole thing out. Sometimes they just say bins, but I like binom. Where N was how many fixed shots? 6 fixed shots. And P was 0.8. So the probability that it took exactly, that I got exactly 4 successes out of that is going to be N, what was N? 6. C, what? What number goes in here, do you think? 4. Which means I had how many successes? 4 successes, and how many failures? Do you see what I did there? So that means I'm going to do 6 C4, which is 15, times 0.8 to the 4th, 0.2 squared. And since that just stops nicely, I'll stop it. Okay? Uh-oh. Uh-oh. Oh. Boo. Hiss. Why am I booing and hissing? Because you've got those at least and at most words. Do me a favor. Grab your calculator. Why aren't you showing up? Oh, I haven't hit it yet. Okay. In your calculator, I want you to go to second vars. Everybody there? Arrow up. Do you see what I see? Do you see what I see? Binomial PDF, binomial CDF. Some of you may or may not have the inverse binom. Don't worry about that. Don't worry about Poisson. We're not doing Poisson. It's not poison. It's not a type of fish. Poisson distribution, we're not doing that. We're doing binomial and we're doing geometric. I want to show you something that we've done. A was geometric, right? We had exactly one value, correct? So that means geometric P per one answer. I'm going to do geometric PDF where the probability of success was 0.8. And I was looking for that success to occur on the third arrow. Do you see what I see? For yours, you're going to do, yes. Okay, yes. You will get an arrow if your probability is not between 0 and 1. Okay? B doesn't really make sense for geometric or binomial, so we don't do that. But C is saying the probability that it's on the 4th or the 5th. I can do second vars, arrow up, geometric PDF, find the fourth, add to it, PDF, that it happens on the fifth. See how that's the same thing? I can add those pieces together. I can do binomial. So I'm going to go to second vars, binomial for one number. How many trials am I doing? 6. Probability of success. How many successes was I looking for on D? Same number. The reason why I waited to show you this is because sometimes on the AP exam, the answer will not be given to you in the decimal form. The answer will be given to you in the equation form. And I want to make sure that you can recognize that. But you can always end up plugging it into your calculator to see if you get it. But the reason why I switched to calculator here is because of E and F. E says at least a dead pen. At least 4 bullseyes. Is this binomial or geometric? Is this a go until or a set number of trials? This is a set number of trials, right? So my set number of trials, this is going to be binomial. Where how many set number of trials? 6. What's the probability of success? 0.8. So what is the smallest number of successes I could have out of those 6 trials? Smallest number possible, not just in this problem, but possible. 0. What's the most? 6. So if I want to have at least 4 bullseyes, that means I go from 4. Do I include 4? Yes, because 4 is at least 4. But do I want the bigger numbers or the smaller numbers? Bigger numbers. Those are the ones that I want. At least 4 bullseyes could mean I have either 4, 5, or 6 bullseyes.
I was thinking that was bullseye.
Yeah. Total number of successes. That's why we're doing binomial here. Now, you can either think of it as binomial this guy plus this guy plus this guy. Or would you rather be able to do it just once? What I can do is, because we're talking about one of those at least problems, I can do 1 minus the probability that is within 0 to 3. So I'm talking about doing 1 minus those. The reason why I want to do 1 minus those is if we look at our calculator, we're doing binomial. PDF is for exactly one value. CDF will allow me to do a range. But if you're doing CDF, it must start at 0. I cannot use CDF to do 4, 5, and 6. Does that make sense? CDF is always going to start here, and it's going to tell me go through what number. So I'm canceling out through 3. So I'm going to say 6 trials, where the probability of success is 0.8. I'm crossing out through 3. So I'm going to do 1 minus that. You can put the 1 minus binomial CDF if you'd like. And by the way, this is the one place where CalcSpeak is acceptable for your work. 1 minus Binomial Cdf, where n is 6, p is 0.8, x is 3. And that gave me 0.9011. And if you want the 2, go for it. X is 3 because whenever you're dealing with CDF, it must start at 0 because that's the way the calculator is always going to do it. So I can't do 4, 5, and 6. So instead, if I want to start from 0, I can use the go through 3, but subtract that out. So I'm talking about my calculator will find that for me. I'll subtract that from 1 to get what's left. All right? Whereas looking at F, tipping stuff over, F said probability that you have at most 4 bullseyes. So again, I can go as few as 0. If I'm talking about at most, can I include at most 4? I'm including that 4. Am I smaller than 4? I'm wanting the values that are smaller than 4. I want these guys. So am I going to do the 1 minus on this or just the stuff? Just the stuff. So I'm going to do binomial CDF, where n is 6, p is 0.8, x here is, I'm going up through 4. 4 is the last number that I'm including in this. So I'm going to do, binomial CDF from 6 to 8, but this time I'm looking at 4. PDF is what we did when it's just one value. So you can either do the NC 6 over 4 and then the probabilities, or you can do just that one. The reason why we're doing it this way is because the other acceptable amount of work for E was that. This is doing a binomial PDF, a binomial PDF, a binomial PDF. So adding it together 3 different times. But didn't we get the same number for ours? And for F, I don't want to add it all together that many times. And then I'd have all of this 1, 2, 3, 4, 5 different times. Or you can just use the calculator command. Okay. Switch it up just a little bit. Same general setup. When we're looking at this, and I ask you, how many bullseyes do you expect her to get? Is that geometric or binomial? Binomial, because it's not a go until. It's what is the number I'm looking for. So we're still dealing with the same situation, so I'm not going to define anything else. For 20A, we've said binomial, so I'm using my y. What was my formula for the expected value? Should have written that down before. What was your formula for expected value? Not 1 over p was for geometric. Nope, this wasn't the NC. This was just the expected value. NP. So number of shots, how many shots am I taking? What's the probability of a success? That's all you do. And 6 times 0.8 is, so we would expect 4.8 bullseyes. Okay. B was for the standard deviation is what it was asking for. What's the formula for standard deviation for binomial? Square root NPQ. So that is the square root times 0.8 times 0.2 What do you get? 9.7. Let's just do 9.8. Of bullseyes. So I want you guys to do number 20. 20C. Think about what kind of a situation this is. Okay? What am I asking you to find on this one? Expected value for geometric. Good. So expected value for geometric is 1 over P. So it's 1.25 shots. Okay? All right, let's take a pause here. I do not like the pace that we've been going at. So I need to ask your opinion because it affects you guys. I know you guys don't care if I push back a test. You like that. But the thing that I'm worried about is that the test would then be after Thanksgiving. Are you okay with that? So this is what I'm thinking about doing. We are going to, today is Tuesday. We will still be working on this on Thursday. But I don't want to do the quiz on Thursday. We can do the quiz on Monday. And Monday we will do that. We will do the quiz. We will answer any questions that you guys have. The day we come back, that Monday, would not be the test day, but it also would not be a review day. So we would start the next little lesson or the next chapter with that. Because I'm not going to give you, I don't care, I'm not giving you a test the day we come back from even a long weekend type thing. Would you guys be okay with that? That's all right? So that means that I will change the test to Wednesday, December 4th. Monday, we're going to take the quiz over chapter 16 and then do some review. Yes, I would push back Khan Academy. I would push Khan Academy back to Monday. Okay? All right. Then I want to add one thing to this. I'm not quite so sure what happened on the quiz. I personally think all the questions are extremely reasonable and that we've done, gosh, especially for the back, we did the exact back multiple times in class, just under a different condition. So I'm adding a homework assignment for you guys. Oh, please, don't freak out. Your homework assignment, I want you doing corrections on this. It's not getting you points back. It is a homework assignment. Do you understand what I'm talking about? For accuracy. Because and what I want you guys to do is this. Please listen. I want you, hang on, Eden, and then last name, There you go. I want you to, on a separate sheet of paper, write down the problem you missed. You do not need to rewrite out the entire problem. I want you to tell me why you got it wrong. What did you do that was wrong? And then I want you to do it correctly, showing all of your work, even for the multiple choice questions. Does that make sense? Okay, so I want you guys, again, you're doing corrections on this. This isn't an added homework assignment, and it is going to be graded for accuracy. Okay, that means if you had any notation issues, I want to see those fixed. I want to see the work for multiple choice. I want to see it all. Okay, that will be due on Thursday because I would like to be able to go over and talk about these in class to make sure that we're all okay. Everybody good? Because I really, honestly, I'm not being sarcastic here. I do not know what happened. And I would like you to examine it to figure out if you knew what happened or if you can figure out what